This is a topic on transport of gases in the atmosphere. So the transport occurs in the atmospheric boundary layer of the atmosphere, and the atmospheric boundary layer is turbulent. Because of this turbulence, it mixes the trace gases for a height of 1 to 2 kilometers. Usually daytime is more turbulent than nighttime. Now the mixing over the oceans is not so evident as over the land. Trace gases will either end deposited onto the surface, that means it will settle onto the surface, or it could also be transformed by reaction, or even go into the troposphere where it is distributed uniformly around the latitude belt in a few weeks. That means it's a few weeks residence time. Now the transport of these chemicals in the tropical regions is restricted due to the general circulation pattern of the globe, where in the northern hemisphere it's mostly influenced by the fossil fuel emissions, but in the southern hemisphere it's mostly influenced by emissions from the ocean or biomass burning. It's one of the reasons why it's mostly from the oceans, because the southern hemisphere has a large ocean surface compared to the northern hemisphere. Chemicals in the troposphere is maintained in the troposphere mostly, and this can also be said the same for the chemicals in the stratosphere, which means that the chemicals are mostly contained within individual layers. Generally, in the tropics, the gases are transported upwards, while in higher latitudes or lower latitudes, the gases are transported downwards. The ultimate stage in the life history of a chemical or a gas in the atmosphere is the removal of this gas or chemical. And this removal is through its sinks. Now, sinks could either occur through transformation or deposition. Now, if it's transformation, that means the chemical or gas would change to a particle because of a reaction, or gas to particle conversion. Aside from transformation, there's also a deposition of these chemicals, and they could deposit onto the Earth's surface or the vegetation of the Earth's surface. And we can quantify the rate of this deposition through the deposition velocity parameter, and the unit is in meter per second, or basically length over time. Deposition can be further categorized into two. There's the wet deposition and there's the dry deposition, where for the wet deposition, the gases or particles are scavenged by the clouds or precipitation or rain. And this deposition process is much faster than the dry deposition process. Now for the dry deposition process, it's a direct collection of gases and particles by vegetation. Solid and liquid surfaces, this deposition is slower than the wet deposition, but it's more continuous, or happens consistently throughout the atmosphere, spatial and temporal scales. One very important sink of gas is the ocean, because of the massive scale of the ocean, but how well the ocean accepts or absorbs these gases dependent on the saturation level of the ocean.